Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
The chapter that we will discuss today is complex numbers. We have solved already 14 questions, 13 questions from the exercise 5.1, and today in this class we will solve the last question from the exercise 5.1. Right. The last question, the 14th question is expressed in the form of a plus ib, and this is the thing that is given to you. Alright. Now what you need to do is you just have to simplify this and finally arrive at a point where you can say that, well, this is in the form of a plus ib. Right. So ಏನು ಮಾಡಬೇಕು ಇದನ್ನು a plus ib form ಅಲ್ಲಿ reduce ಮಾಡಬೇಕು, simplify ಮಾಡಬೇಕು. Alright, so let's begin. First, what you will use, this is multiplication, therefore we will multiply. Okay, so this is a plus b and this is a minus b, so you can write a square minus b square. Okay, so now first what you do, this is a square minus, see this is b square, so I will write this way. Right. So b is ib here. Right. Okay. So divided by. Now look at this. Don't go for multiplication. You have multiplied here, fine. But don't go for multiplication. Why? Do you see this negative minus sign here? Okay. So this is subtraction. You don't have to multiply. So many students make this mistake. Okay, so here they multiply and here also they multiply, but there is a difference here. This is multiplication, this is subtraction. So that point, if you notice, then you will not commit any mistakes further. Okay, so e point on this way minus ಇದೆ, ಇದು ಮಾತ್ರ multiplication, ಇದು multiplication ಅಲ್ಲ. So ಏನು ಮಾಡಬೇಕು ನೀವು ಬ್ರಾಕೆಟ್ ಅನ್ನು ತೆಗೆದು ಮೈನಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ. Alright, so this is root 3 and this is root 2i and multiply minus inside, so this is minus root 3 minus and minus right, plus I root 2. Well, the next step what you can do is you can add these and these two things gets cancelled. So this is 9 minus I square and root 5 whole square. So root 5 square is 5 itself divided by. Okay, now here this is the root 2i plus root 2i, so 2 times root 2i. Well, now next replace I square, so this is 9 minus 1 in place of I, and this is 5 divided by 2i. Okay. So now what is happening here? 9 plus 5. Okay, so I'll write that step, then we can write down the okay. So what is the next thing? 9 plus 5 is 14. Now 2 1 2 7, so that will be so what is it? 7 divided by root 2i. See, this root 2i is nothing but 0 plus root 2i, correct? So what is the conjugate of this? 0 minus root y. So what you have to do if you want to rationalize, see, when you write a plus ib form, in the denominator you should not have I. Denominatorly I ಇರಬಾರ್ದು. So ಏನು ಮಾಡಬೇಕು ನೀವು ರಾಷನಲೈಸೇಷನ್ ಮಾಡಬೇಕು. ಸೊ ರಾಷನಲೈಸೇಷನ್ ಮಾಡುವಾಗ ಕಾಂಜುಗೇಟ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಡಿವೈಡ್ ಮಾಡಬೇಕು. Alright, so now I am multiplying and dividing by the conjugate. So what is the conjugate? If a plus ib is the complex number, a minus ib is the conjugate, correct? So a minus ib is 0 minus, so only imaginary part sign change ಮಾಡಬೇಕು. Imaginary part ಅಲ್ಲಿ ಮಾತ್ರ sign change ಮಾಡಬೇಕು. So this is minus root 2i. So this is minus root 2i. Okay. So now 7 and minus root 2i, you can write this way, divided by, see this is minus well, root 2 into root 2, that is 2, and I into I, which is I square. So minus and minus, you can get it off. So this is 7 root 2i divided by 2 into minus 1. Well, so this is like 7 root 2i divided by minus 2. Okay. So finally, what you can write is 0 minus 7 root 2i by 2. Or if you want to simplify further, see this root 2 and this 2 can be simplified. How? So this can be written as root 2 into root 2. One root 2 can be cancelled. Okay. So do you want to do that? Yes. Alright, this can be asked for 3 marks. Okay. So 0 minus 7 root 2i divided by root 2 into root 2. So that 2 can be written as root 2 into root 2, correct? Okay. So now 1 root 2 is cancelled. So 7 by root 2 I. Or you can get plus here, minus here, that is also fine. Okay. So this is of the form a plus ib. Okay. So a plus ib, where b is minus 7 by 2. So that's how you can simplify this question. The next question that okay, so that completes this 5.1 exercise. Now what I told you in the previous class is this: we will understand how to plot a complex number in the graph. Alright, so that is called Argand Plane. Alright, so this is called Argand Plane or complex plane. Okay, or complex plane. Now what we will do here is this: I'll give an example and you can understand. Right. So let me consider one complex number 2 plus 3i. Is it in the form of a plus ib? Yes. So this is in the form of a plus ib. Now I want to represent this in the graph. Right. Now in the graph we don't have real axis. See, in Cartesian coordinates, okay, in the Cartesian coordinates, you have x-axis and the y-axis like this. So this is negative x-axis, negative y-axis, correct? So if you want to mark, let us say 1, 1, 2. So what do you mean by 1, 1, 2? X is equal to 1 here and y is equal to 2. That's what we mean by that 1, 1, 2. So x is equal to 1, alright, and y is equal to 2, let us say. Okay, so this is 1 and this is 2. and this height is 2. So this height is 2 here and this length is 1. So that's how we understand this Cartesian coordinates. Now you don't have real number here. So this is imaginary 3i. Correct? So what we must do is we must have a real axis and one imaginary axis. So this is real axis and this axis is imaginary. Now on the real axis you plot the real number. So what is the real part of z? So real part of z is 2 and the imaginary part of z is 3. Now on the real part, on the real axis, we must represent the real part of the complex number z, okay, and on the imaginary axis we must plot the imaginary part of that complex number z. Alright. So on the real axis you have to go for 2 parts and on the imaginary parts you should go for 3 parts here. Right. So now this is the point which represents 2 plus 3i. Right. So simply what we write is, we just write this here. So this is 2 comma 3. So what is happening here? Every point on this plane. Okay, what plane is this? Argand plane, or this is a complex plane. Right. So this is the complex plane which represents, okay, the complex numbers as points. So what we can do is we can relate every complex number to a point in this plane. So how many points are there? Infinite points. So this is real. Okay. So you have 2.1, 2.2, 2.01, 2.001. So you have all the real numbers here. So there are infinite points. All these points are there. Okay. So there are infinite points. All these infinite points can be assigned to a complex number. Okay. So ಎಲ್ಲ ಪಾಯಿಂಟ್ಗಳಿಗೆ ಒಂದೊಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ನ ಅಸೈನ್ ಮಾಡ್ತಾ ಹೋಗಬಹುದು. So we can connect the complex number to a point. So every point represents a complex number. So every point in the Argand plane. So this is not Cartesian plane. This is Cartesian plane. This is complex plane. You have real axis along the x-axis and the imaginary axis along the y-axis. So that's how this Argand plane is explained. Now we need to understand 2 more things here. Now what I'll do is I'll just draw this line. Okay. So this is the origin, let us say, and this is let me take A. Now what is this length OA? Right. So how do you find this length OA? See, this height is 3, is it not? And this length is 2, obviously. Right. Now if you use the Pythagoras formula, see this is the perpendicular that I have drawn. So if you use the Pythagoras formula, let me name it OA and this let me name it as B. So this length is 2. Okay. Now if you use the Pythagoras formula, OA square is equal to OB square plus AB square. Right? Okay. Next, what is OB square? So OB square is 2 square and AB square is 3 square. Right? Okay, now this is 4 plus 9. So what is it? 4 plus 9. So you have 13 and this is OA square. So if you need OA, that is square of 13. then this point would be A comma B, and not. And what is this length? That would be A, and this would be B. If this point is A comma B, then what would be OA square? So OA square would be A square plus B square. And what would be OA? Square of A square plus B square. Now, do you understand what does this represent? So, what is this actually? Square root of A square plus B square. So, we have learned that already, and that represents actually modulus of z in R. So, modulus of z is nothing but this square root of A square plus B square. Therefore, OA length, this length OA is actually the modulus. Right? What we understand is every point represents a complex number, and the length of the point from the origin is its modulus. Okay, so what is the modulus actually? It is the length of the point from the origin. It is the distance. Okay, it is the distance of the point from the origin. So that distance we can name it as modulus of z. So now did you understand what is the geometric meaning of modulus? Okay, so next what do you mean by conjugate? Right. So what do you mean by conjugate? Right. So next I'm talking about a conjugate. So here, if z is equal to a plus ib, okay. So in this case we have taken 2 plus 3i. So what is the conjugate here? 2 minus 3i. Imaginary part mark sign change model. Wow. Next, what is this z bar? So this z bar is a minus ib. Okay. Alright. So now understand that is 2 plus 3i. So this point is 2, 3. Now I have to plot z bar. Alright. So z bar is 2 minus 3i. So along x-axis 2 itself, but along y-axis it is minus 3. Along y-axis imaginary part minus 3. So minus 3 on the negative side of y-axis. So this is minus 3. So where I have to plot? So I have to plot here. Right? So this point is 2, minus 3. So if this is A, B, then what point will be this? Will this be? So this point will be A, minus B. And this represents the conjugate. Okay. So if this is the point, then this is the mirror image. So this is the mirror image. Alright. So and this represents the conjugate of the complex number. So the complex number, if it is 2 plus 3i, its mirror image is the conjugate. Right. So understand two things. First, the modulus is okay. So modulus of z, that is the distance from distance of the point. So distance of the point from the origin. Right. Then now what is the conjugate? Conjugate is the mirror image of the complex number Z. Alright, so this is about modulus and conjugate expressed in the Argand plane. Right. So this is about the Argand plane. So I'll just recall what I mean by Argand plane. Okay. So Argand plane is the plane where x-axis represents the real part of the complex number and y-axis represents the imaginary part of the complex number. And any complex number can be plotted in the graph, and that represents a unique point. Okay. So every complex number is related to a unique point in the plane. And what is the modulus? Modulus is the distance of the point from the origin. And conjugate is the mirror image. So if this is a mirror and this is the point, so that is the image of that point. Okay. So if you look at the mirror, your image will be on the opposite side. So that distance is equal. So this distance is equal. Well, so I hope you understood this part very clearly. Right. So there are no questions connected to this, but you need to remember the geometrical meaning of this modulus and conjugate. Well, so that's it for this class.
Don't forget to like our video and subscribe our YouTube channel for all the updates.